So let's talk about TypeScript again. I've prepared a first question for you. How are you? This is tricky. I think we are all a little bit tired, but let's try to keep for some few talks. So TypeScript. Today I want to share with you my experience with TypeScript, of course. So the man that thinks to know TypeScript was me, and is still me. So I want to share with you the process of me trying to be good with TypeScript and what I've learned during these years. And at the beginning, it was most like, okay, with TypeScript, I can stop all the errors before runtime. That was really a nightmare for all web developers. On the console log, find some red flag, but we still have red things. But TypeScript tried to save us from that, you know. And so at the beginning, it was like, okay, I'm a JavaScript developer. I just have to add types. So it's really easy. And this is what Node now try to keep back. So just add types. It's really easy. And then I discovered that was way more during the years. So I will take with me, this is not Ghibli style, so we're okay. I will share this journey. And after a few minutes using TypeScript, I think all of us learned that there is a magical tip to uh, fix every error. And you know, it's any. With any, we are safe again. And this is really cool. And I also find this tip about making an alias for any, because a lot of time when you are in a rush, you have your customer asking you, okay, I'm not using any, I'm using to do. But still, after a few years, I understand I should never use any, of course, because this is not the goal of using TypeScript, right? Because any just make our type safety disappear. So as an example, if you have an any somewhere, for example, we have a data, here is an any, you can actually do whatever you want. You can treat it like a string, like a number, and then you will find some errors later. And so, but if you think about something I don't know, like that, I don't know what data is, and we have a lot of time that this happens. Well, it's easily, we can easily use a similar word. So is unknown something. So it's where you can start with unknown to manage what you don't know. So for example, here, I've just used unknown, and you can see that now TypeScript is telling me you cannot use an unknown type as a string or as a number. So you need to start making type guards. You need to check which type you want to manage, and after that, with narrowing, you can actually use the types. And for example, here we have a typical use case with error in a try and catch because it's unknown. And if you want to print a message, if you want to, maybe you have a custom error, you can do whatever you want. And still here we have different type guards, and we can do better than this because there is too much code here. And so something I learned after this is another cool stuff about TypeScript is type predicate. That it's a magical thing. TypeScript has a lot of magical stuff, but still I love TypeScript. Because for example, here we have, this is what I used to do. Okay, I want to make a check on the type, a type guard. So I want to be sure that something, for example, is a string. And this is working. The string will return true if I'm passing a string. But of course, this is still data, is still a variable that could be both string or number. I want to make a narrowing of the type. I want that data on that scope is an actual string. And this is how type predicate can help me, because if the return type of my function is value is string, that literally means value is string. So it's easy. I can use data as a string on the scope where I've used this type predicate. And this is TypeScript magic. And of course, in the else statement, so in the next scope, TypeScript will understand that we had the number. So with type predicate, we can also manage in a better way, in an easier way, our code. if we took the error management we see earlier, here is the same, but the code is cleaner. So we can use type predicates to write some helper. That is cool. Another thing that I really loved about TypeScript, of course, union. Union are really nice on types. But something that I really loved the first time I saw it, I implemented in my project, are here, are discriminate types, because you can have like complex applications. For example, the first time I used discriminate types was for a custom editor where we had custom blocks. So this is where you need to create different logic for different types. So you have something like an union. Here we have vehicle, which can be a car or can be a camper van. We have two objects that are similar, but we have a discrimination on the type literal, so a car or camper, and we have different attributes. And so I cannot do something like here, like this, on vehicle, because vehicle can be both a car or a camper van, and just the camper van has beds, as we all know. And so I can just make a check on the type of the attribute type that can be whatever we want. We just need an attribute to make discrimination between our different types on the union. And here I can use finally my bets, because making this kind of check on the type attribute, I can just be safe about the type I'm looking. So here we have the campervan type. But what happens if I add another type? This is still cool, because if we go back here, I'm adding motorcycle, that is different. I had no errors here because I'm not checking anything else. And this is where I start using exhaustive check, just adding a default behavior on my switch case. Now I'm trying to assign vehicle to never. Never is a type that should never happen. And here I'm trying to have another type on vehicle. So I expect that after managing all types, never will be the type of my object. But here I've added motorcycle, so this is where I will get an error. So TypeScript will always check on me. And then I started also playing with utility types that are really cool. I will be faster because we saw a lot of magic with Luca yesterday. But of course, I think all of you start using different utility types to manage objects. So you want to make everything conditional, or like pick something, everything read-only. They are cool. Something I use a lot is parameter type and return type. So if I have a function, I want to have the return type and the parameter type. I don't want to write code and be like and copy some type definition. I always want to have just one source for my type definition. And with this utility, you can have from a function. But of course, maybe you have like a promise, so you want to manage the promise. Because when you have a promise, the return type will be a promise with something that will be on the x-axis of your promise. And if you want just the resolve type, you can use a weighted, that it's another utility. So you have an utility for a lot of different things. Other utilities that are really funny to use, and you can do a lot of different things, are for string manipulation. You can really create a lot of different stuff. They are really useful. For example, if you want to map your object with something else, here is an easy example of just rewriting my type, adding a prefix get, and you can play with different stuff. Here we have the key of, the as, and then we use the capitalize. So, and you can play with different things on TypeScript just to build on stuff. And you remember from yesterday that we can really make gymnastics with that. And you can also use these. On the front end, sometimes I use that for especially for CSS. Sometimes I have to write custom CSS class. This could be an easy way to manage using existing types. Another cool stuff about types are that they can be recursive. The first time I use recursive types, I remembered about my university years where I was in the nightmare of recursion. And here I started again, but now it's easier because here you just can use that for example, here when you have nested type and you need to create a structure like this is a JSON that will have different level. You can use it the type recursively, and I actually use that in a project. This is a simpler version for translations, because when you have, if you want to implement your own localization system with different languages in your project, you will have big dictionary of strings. So you will have like a JSON with dynamic trees with keys, but I want to be type safe when I call some key for my translation, right? So how can I check that on title exists and on description is not? I can use recursion again, because this is a dynamic tree. So for example, here the code is a little bit less readable, but still it's just about mixing all these concepts, because I make recursion just to get deeper in my tree. I will use join to make, I will use conditional types, I will use generics, I can use literals, I can use a lot of things, and of course AI will help you to write stuff like this. But then there is another things about TypeScript that make me, I thought with types I was okay, but I think something that every time I have to implement is always a little bit tricky is interfaces, because especially the first time you see a type and an interface, they are pretty the same, and you start thinking why. But then you go deep and you see that they have different characteristics, a little bit different characteristics, but it's not that one is better than the other. In some cases, they have big difference. For example, how you can do things like this on a type. If I want, I can make an intersection. So here, my type animal is with cat. With interfaces, I can extend. And so here, I try hard to understand, with Pocock, with these TypeScript gods, to understand what I have to use. And pretty, the solution is easier just when you have to extend some types to a bigger one. It's the interface use case. In the other cases, usually types is okay. But one really cool stuff about interfaces are merging, because when you declare with the same name two interfaces in the same scope, they will be merged. And this is really useful, not here, because I don't know who use cats in their application, but we will see some real example. And of course, remember that when you merge two interfaces, the new attribute will be merged, but the old will be override. And this is really important to remember. For example, you can extend the window object. So you need to use a new window attribute, and you need to add the type definition. You can merge in the window interfaces in this way. Or, for example, in Out.js that was next out, you need to use your custom object, and they just told you you have to write this, but this is just interface merging. You are declaring in the same scope the same interface name, so you are merging in their interface new stuff. And of course, remember that for example, here in session you have user. Writing this, you are overwriting the user definition, so you have to remember to keep also the original definition, and this is an intersection. Or for example, in Tanstack router. How many of you use Tanstack router? And so Tanstack start. Someone Tanstack start? Well, you should, because it, I think, will be really a good framework in the future. But all the environment in Tanstack is really cool. So router, query, table, form from a friend. And for example, here, this is a routing system for React. And you can have type safety while using routes. That is really cool. It's something that we miss in Next.js, for example. And you want to be type safe, you want to have a query parameter, everything should be typed. And they told you have to, when you create your router with your route tree, just make interface merging and tell us which type is your router. So cool. And this is not something that I use a lot, but you can also make your environment variables type safe, always merging your interface. And what about React props? This is just a joke because as a front-end developer, for the most, I always had the doubt what I should use, interface or type, because also libraries are not the same behavior. It depends, and I was really in doubt. I use interface for the most, and I think it's the right decision for a lot of reasons. But when you have doubt about React, you just ask to the React God, and Fabio told me just use interface. So just use interface. Don't ask yourself again. And but we are type safe for a lot. We are talking about the type definition merging, but then you have backend talking with you, or you are the backend, you have to talk with front end. Maybe there are different languages, so you are TypeScript developer on the front end, but there is something else on the backend, or there is TypeScript on both sides. This is where you get problems because a lot of times I talk with other backend developer and they told me just this is your data, enjoy, and I want to know which type I have to manage. Other times, I'm the backend and front-end developer, and it's easier. And there are a lot of different ways that I've learned during the years, and now I feel very strong of having type safety here. And when a backend developer is not helping me doing that, we get troubles immediately because there are ways to share types. Of course, you can define your type. Of course, you just define an interface and use this. You use the directly. Uh, you have to maintain it. You have to be consistent. It's a nightmare. And of course, you can have like this cool generics where you manage different cases, but still you have to maintain it. You shouldn't define things that you are not developing, right? And for example, you can have solution. For example, if you use tRPC, and so you define in a monorepo or in a common code base with tRPC, the backend and front-end definition of APIs, you can share. Just like here, we have app router, and importing on the client side, I just infer all my types in tRPC. So I know exactly which type, and I didn't define anything here. So tRPC is really cool. It was really, really cool in the past also. In the monolith with Next, now they are a little bit tricky. But other solution, for example, you can have GraphQL, of course. GraphQL is an API gateway, it's really powerful. You have your own query language that is pretty nice. I love GraphQL for some reason. But also here, you shouldn't define something that is already defined somewhere. And that's where you can use code generation. Code generation is way older than AI generation on code. And it's very powerful because you can automatically have your type definition on your front end without have to check it manually. And this is the actual production. And a really, really cool standards that now we are using a lot is OpenAPI. It's really a great standards to define API schema. You have Swagger, you have a lot of cool stuff. And so you have your schema on OpenAPI. You can use code generation and you will have your type and you will use directly these types. That is really cool. And you can also define Zod schema. I don't know if how many of you use Zod, but you can make also your client validation generated by API schema. I think this is awesome because you can add this generation on your flows. For example, I used to implement it a lot, and you can use it in CI, for example. So every time there is something new and someone try to create a PR, I don't know, you can try to generate again your types. And I really love when my backend colleagues told me, I tried to make a PR, but front-end building is failing. Because the response is, you broke the API. So the front end cannot work because I generate the types from there. And now everything is broken and we have to fix it. So it's not having an error at runtime. It's having an error before creating a PR. This is amazing. But of course, you can also use that locally with git hooks. Git hooks is a way to have direct commands on some git hooks. So for example, commit, pre-commit, push. So I can also check whatever I want my types. Of course, it can be expensive, so times can increase. So you have to be sure that you are not going to slow down too much your CI and CD. And this is all, for all this reason, I love TypeScript, because now problems are really on my eyes at the very beginning of the process, because we saw a lot of errors on while we wrote codes, and it's amazing. But some codes that are a little bit tricky to find can be somewhere also in the integration between front end and back end. And for all this reason, I love I love TypeScript. This is funny because this is the version of me created by OpenAI. It was a little bit creepy, but I think it was the right way to finish. So thank you.